Right, good morning, Year 8. So what we're going to be doing today is we're going to be looking at how certain pathogens, particularly bacteria, change and why this can cause a problem. So all of you should be able to know how antibiotic-resistant strains of bacteria arise. Okay, so how do we get these bacteria that are resistant to our antibiotics? Describe how mutations in bacteria can cause new strains of disease, and evaluate the problems preventing in the spread of the disease. Now, this is probably going to run into 2 lessons because there is a video that I'm going to show you probably on this lesson. Okay, so quick recap. Firstly, what I'd like to do is draw a table with bacteria and viral and try and identify which of these go on which side. Okay, so pause the video now and do that, please. Okay, so the ones you should have had. MRSA is a bacterial infection. Now that stands for methicillin resistant Staphylococcus aureus. Don't worry, you don't need to remember that. Obviously, it's resistant to something called methicillin, okay, which you'll learn about later. Tuberculosis, that is also bacteria. Flu is viral, and AIDS is viral. Although actually that's a bit of a misdemeanor because actually that should be HIV, and AIDS is actually the syndrome caused by this virus. So that's not quite right, but there we go. Right, so the first thing we're going to do is we need to understand what antibiotics are. So in assignments, there's going to be a link to this video clip here. I'd like to watch that, and then we're going to come back and answer this question. What are antibiotics? So do that now, please. Okay, so in a nutshell, what are antibiotics? They are a type of medicine. Now, here is the really crucial part that you need to know about antibiotics. They can only be used against bacteria, and that is something that you must have in your book. Okay, they can only be used against bacteria. They are useless against viruses. They do nothing against viruses. They can only treat bacteria infections. Okay, so you remember I asked you to draw out the differences between viruses and bacteria. Antibiotics will do nothing, say for example, against flu or colds or the coronavirus. It won't do anything against those because those are all viruses. It only treats bacterial infections like tuberculosis, cholera, that kind of thing. So can you put that in your book, please? Secondly, they are used inside the body. Okay, so now if we want to kill off bacteria, actually viruses as well, we would use things like soap to wash our hands and alcohol gels that you find, but we can't really use those inside the body because they're toxic to our cells as well as to the bacteria cells. So basically what would happen is if you used, say for example, a high level alcohol inside your body, what would happen is you would kill the bacteria or virus, great, but you'd also kill all your own cells, so that's no good either. All right, so we've developed medicines which can work inside the body. Okay, now the reason they don't work against viruses is because viruses get into your cells, whereas bacteria work outside our cells in the spaces between our cells. Okay, and the reason bacteria make us sick is because they produce waste products, toxins that make us sick. So antibiotics are medicine. They can only be used against bacteria and are for use inside the body. And hopefully from watching the video, you know the basics of how they were developed. So the very first antibiotic which was developed was, hopefully you pick this up, penicillin, which some of you have probably heard of. It's the first antibiotic, and originally penicillin was developed by mistake by mold. However, quite a good mistake, because during the Second World War, it was a case, in fact, sorry, during the First World War, more people were dying from their wounds, from infections from their wounds, than from the actual wounds themselves. If you got shot, you might be perfectly okay, you might have got shot through the arm or something, but it was the infection that got in that was killing more people than actually the bullet wound itself. So actually penicillin was a real breakthrough. It was very, very important. And then from there, we developed a whole load of other antibiotics which can kill bacteria. However, there is a problem. Penicillin and other antibiotics, bacteria are starting to figure them out. And I will show you what I mean. Okay, so in a moment, I'm going to ask you to watch this clip. And once again, this is in assignments. Okay, so let's just say you've got a whole bunch of bacteria. Mostly bacteria are the same, but just like people, you can see they are slightly different here. I've got slightly different colours. There's a little green one, a blue one, a couple of orange ones, but mostly they're yellow. Now, these differences, just like in us, are caused by mutations, very slight changes to your DNA that lead to differences. So here we have a group of bacteria. Now let's just say one or two of these changes can lead to a resistance against antibiotics. So let's just say the orange ones, their mutation is beneficial. The other mutations haven't really done anything, and these ones haven't mutated. So, say for example, we bring in an antibiotic and it goes pew 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 like that. What we're left with are just our bacteria who are resistant to this antibiotic. Now, as we know, bacteria can proliferate, which basically means grow and multiply very quickly. So what happens is this: 1 becomes 2, becomes 4, and so within often a matter of a few hours, we find that these bacteria have all multiplied again and are maybe a bit and are back. And of course, now we've got the problem that they're resistant to this antibiotic. Now, even within this population, you might get the odd one which has a random mutation. So let's just say make these nice and deep red. Okay, now this random mutation is different from the first one. So now we've got a whole population of bacteria that are completely resistant to this antibiotic. So now what we need is we need to develop a new antibiotic, antibiotic number 2. So this one comes in and pew, 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 pew. It kills all the new resistant bacteria. But of course, this random mutation here means that these two are lucky enough to be able to resist this new antibiotic as well. So then they proliferate, and once again, within a matter of hours or days, what we have is a new, what we call superbug, a super bacteria, okay, which is resistant to this antibiotic and this antibiotic. So you can see what the problem is starting to be. These bacteria, it's like an arms race. Every time we create a new antibiotic, they're randomly evolving and becoming resistant to them. Okay, it's not a conscious choice. Bacteria don't think. It's just their random mutations make them happen. Okay, so what I would like you to do is pause the video and just draw maybe like a miniature comic strip, so like a 3-block section showing what happens, and then explaining how do bacteria become resistant. So basically you're answering this question: how do bacteria become resistant? If you haven't already watched it, it might be a good idea to watch the clip before you do that. But essentially keep it simple, okay? Shapes, colours, okay? So you started off with some bacteria with random mutations. That gave them resistance to the first antibiotic. So those ones then survived and passed on their genes. Then we had to introduce a new antibiotic that came along and killed again most of these new resistant ones, but a few randomly had what it took to survive and passed on those genes and proliferated. So by the end, you had a bacteria that was resistant to both antibiotics. Okay, so you need to explain that process. So using a comic strip or storyboard or something like that would be a quite good way of explaining step by step how this happens. So pause the video and do that now, please. That'll probably take you about 10 minutes to quickly sketch up little things like this and a couple of sentences to explain how each step actually happens. Okay, off you go. Okay, now this is the activity in assignments. I'm just going to explain this through to you, or the first one. This is really designed to show you how quickly bacteria reproduce and also how quickly they can be killed. So, improve your understanding of the rapid reproduction of bacteria, the action of antibiotics, and how bacteria develop resistance. So, activity number one, what you need to do is collect a beaker of white bacteria and a beaker of green bacteria. Now, you don't have that. So what I suggest you do is maybe just get some paper and just cut it up into tiny, small little squares, and some of them you would keep white, and some of them you can just like put a dot on, or it says here colouring green. So yeah, maybe you could colour them in green. And what you're going to do is just put them all in a cup. Okay, this will probably take you a few minutes to set up. Then place one white bacterium on the desk. Double the number of white bacteria every 30 seconds. So 1 after 30 seconds becomes 2. After 1 minute, what did it become? After a minute and a half, what did it become? So you've got to think carefully. It doubles every 30 seconds. Right, so use a stop clock. You can do that on your phone. And do this for 3.5 minutes. So how many bacteria would you have after 3.5 minutes? Okay, you can plot them on the graph. Now, if you can't print this off, you can just copy it in, draw it straight into your book. That's fine. So this first task, all you need to do is cut up or even just tear up some pieces of paper, colour some in green like that. Okay. Now, we're just going to start with the white bacteria, just being really clear about that. So activity 2, the action of antibiotics. One of the white bacteria mutates to change one of the white bacteria to a green bacteria. They're resistant to antibiotics. The antibiotic is now taken. It kills 20 bacteria every 20 seconds. Keep removing 20 white bacteria every 20 seconds until they are all dead. Okay, so what you would need to do is look at the number that you've got. So you might have to spread them out on the table. How many are left? So what you can do is simply answer these questions then to help you with this. How long does it take for all the white bacteria to be killed? Remember, it kills 20 every 20 seconds. Okay, so you could probably do this in your head if you're good at maths. Describe what is left behind sitting on the table and explain that. Now, it's only left you one line there. You might need a bit more. You might need a couple of lines, so you might do all this in your book. What happens inside a bacteria when it mutates? Now, hopefully from the video, you will have got that. Then the last thing, activity 3, antibiotic resistance. So you've got green bacteria. Double the number of green bacteria every 30 seconds. Use a stop clock to keep track. Continue this for 3.5 minutes. Record your results. So it's very similar to activity 1, except this time you're using green, not white. Then the green bacteria are now treated with antibiotics. What effect will this antibiotic have on a green bacteria? How can the doctor treat this infection? Would the antibiotic be effective at treating flu? Explain. Okay, so by the time you've prepared your green and white bacteria to actually model this, it'll probably take you about 5-6 minutes to set that up, and then counting them using a stop clock on your phone or something like that. The actual activity will probably take a few minutes, and then plotting it on your graph will take a few minutes. So this entire activity will probably take you about 20 minutes to do it properly, maybe 25. So pause the video, print these off, or if you can't print them off, just have it up on your screen and do it straight into your book. And then I'll come back and show you the final task in just a moment. Okay, good luck and off you go. Now, next lesson, we are going to learn about one of these so-called superbugs. It's called MRSA, which stands for methicillin-resistant Staphylococcus aureus. Now, Staphylococcus aureus, or strep throat, as it's sometimes known, is just the kind of bacteria that gives you a bit of a throat infection. However, this one has become resistant to a type of antibiotic called methicillin, which is kind of like a bit of an upgrade on penicillin. Okay, So methicillin resistant Staphylococcus aureus is a very, very dangerous bacteria if it's in the wrong place. Now, we have MRSA often all over us all the time. Most people actually turn out to be carriers and does us no harm at all. But if, unfortunately, it gets inside our body in the wrong place, it can cause us serious damage. Okay, and we're going to do some investigation into that next lesson. However, your final task for today is also in assignments, which is a little bit about you using data. So antibiotic resistance, how has it affected the use of antibiotics? So you've got some data about the use of antibiotics and what that shows. Okay, so I'm going to leave these questions open, and then you can just do these on the sheet directly or in your book, and then upload them later. And this will probably take you about 10 minutes to do. If you can't quite manage the challenge, don't worry too much. I'll probably go through that at the beginning of next lesson. So, good luck, Year 8. As always, I'll be online to help you if you need me. Off you go.